So now we're going to close up here by going back and looking at the quantum foam or the ether. And let's see where that takes us to complete our story. This is what's going to fill the arena. We go to the physicist Arnold Sommerfeld, one of the truly great physicists of the early 20th century. And Sommerfeld observed that since there's free space, there's no interaction with matter. There are only waves of electromagnetic energy that propagate in a given direction. But they do have in that direction, they have perpendicular to it a transverse electromagnetic field that is rotating around the direction of propagation. So Sommerfeld saw this, but he also looked at the equations of fluid mechanics, and he decided I'm going to the equations for fluid mechanics and electromagnetism are identical, except that the fluid mechanics equations have extra terms due to the density of the ether of the fluid. So he added these terms in, just we're going to turn the crank. We're not going to say anything about plausibility or anything. But we're going to start with the simplest possible foam we can think of for the ether. It's going to be frictionless. That means it's perfect in that sense. None of the little pieces of foam grate against one another, and it's incompressible. The foam is incompressible. Clearly, that's not true because we had inflation occur at the start of our universe, but we'll come back to that and we'll see how we fix that. And so we see that the equations of electromagnetism are identical to those for fluid dynamics. We add in the extra terms for the spatial density of the ether, and we get a full set of equations for electromagnetism, including the ether and the density of the ether. So now we're going to do some little mathematical crank turning. We carry out a perturbation, expansion, and powers of the ether density, and we find the zeroth order term, but this is simply Maxwell's equations in free space. This is the ether density to the zeroth power. And now we're going to look at the first and the second order terms, ether density to the first power, ether density to the second power. And here we find the strong force where like charges now attract, as in protons in the nucleus of an atom that are all positively charged, but they attract one another at the very short distance in the nucleus. And we also find the weak force. That is, a neutron will decay into a proton, an electron, and a neutrino. So the nucleus that had a neutron in it will now just have a proton in it. The electron and neutrino are gone. And the atom itself has the same number of electrons surrounding the nucleus, but now it has one extra proton, and we call that an isotope. So the strong force creates isotopes. A weak force creates isotopes. So the change in density of the ether is gravity. The greater the density, the greater the force, the greater the gravity. That defines what's going on. Um, so physics arises from the interaction of the ether with the electromagnetic fields. The electromagnetic fields can now support scalar wave propagation, which is the sort of wave propagation you'd see if I took a rope, which is a scalar. It's a rope. It's got one dimension to it. I tie it to a post, and then I hold the other end of the rope in my hand and snap the rope. So a wave goes down the rope, it hits the post. Some of the energy will get absorbed, and some of it will bounce back to me. So that's a scalar wave propagation. So we have scalar waves as well as transverse wave propagation, and this leads to discrete particles or photons that describe light, and they hop from one compartment of the ether to another. That's how they move, as discrete particles hop, hop, hop. So now when we bridge the concept of the etheric foam, often conceptualized in alternative physics, historical science, and metaphysics as a fluid energetic substrate of the universe, with the mainstream cosmological theory of inflation, we find a fascinating parallel. Now, inflation arises because when we look at the stars at night, we see the stars appear to be uniformly spread around in the heavens. There isn't any clumping of stars in one area and there's no stars in another. It seems to be uniform. And that could only occur if there was some mechanism when our universe started up that allowed everything to be smeared out everywhere, even though it was all close together at the start. That mechanism is called inflation, where in a very short period of time, you have typically 30 orders of magnitude expansion in size of these etheric foam compartments. But they're so small to start with, the 30 orders of magnitude in the scheme of things doesn't matter a lot. But over billions of years, it does matter, as we'll see. So how does empty space generate structure, matter, in the geometry of the universe? This is what's going on here with inflation and with the etheric foam that we're dealing with here. Both of them are looking at the same thing. So there's a quantum foam in the ether, and then there's the Calabi-Yau landscape. So how in the world are these two things related? Is there a dynamic high energy froth of space that behaves during the birth of the universe? So in the late 19th and early 20th century, the ether was imagined as a passive fluid medium through which light waves traveled. But as quantum mechanics and general relativity evolved, physicists realized that empty space isn't passive at all. At the ultramicroscopic level, which is the Planck scale, it's 15 orders of magnitude smaller than the nucleus of the atom, space behaves like a violent, turbulent fluid. It's a quantum foam. If you zoom in close enough to a Calabi-Yau manifold or a smooth space-time, the smooth geometry breaks down because of the Heisenberg uncertainty principle. The energy is going to fluctuate wildly. You can fix the energy, the momentum, but then the position becomes fluctuating. You can fix the position, but then the momentum or energy fluctuates wildly. You can't get both. So the virtual particles that are there pop in and out of existence. There's microscopic wormholes that form and dissolve. There are dimensions that twist, rip, and repair themselves. And this geometric high energy froth is a mathematical equivalent of an active, creative, etheric foam. So the foam really is there in the Calabi-Yau manifold. The cosmic inflation, which is the engine that drives all this, is the theory that a fraction of a second after the Big Bang, the universe underwent a stupendous exponential expansion, stretching space faster than the speed of light. So what drove this expansion? An intense uniform energy inherent to space itself, modeled as a scalar field, which is called an inflaton for inflation. During this inflationary epoch, the etheric foam, the micro realm, became the blueprint for the macrocosmos. It stretched the froth. Before inflation, the quantum fluctuations of the bubbles and ripples in the foam were subatomic. The inflation acted like a massive magnifying glass, instantly stretching these microscopic high energy ripples into astronomical scales. And this led to the creation of galaxies. When inflation ended, these stretched out ripples became variations in the density of space itself, in the areas that were slightly denser in the foam attracted more matter via gravity, eventually condensing into the cosmic web of galaxies, stars, and planets that we see today. So if we integrate this with string theory and Calabi-Yau geometry, this is the foam that settles on the landscape. Uh, this is the inflation is the process of the foam trying to find stability. In the incredibly high energy environment of the early universe, the extra 6 dimensions for the matter, compactified matter subspace, were not yet locked down by fluxes. The Calabi-Yau manifold was violently vibrating, changing shape, and fluctuating. It was a literal dynamic geometric foam. But as the universe inflated and cooled, this foam underwent a series of phase transitions. The inflating universe rolled down the energy hills, the cosmic landscape. As the energy dropped, specific units of flux wrapped around the holes of the Calabi-Yau manifold, as modeled by the GVW and KKLT mechanisms, and we had a big freeze. The wild, chaotic etheric foam localized into the Pacific Valley. The extra dimensions crystallized into a fixed shape, locking the laws of physics and constants of nature into place for our specific pocket in the universe. So in many inflationary models, like eternal inflation proposed by Alan Guth and Andre Linde, the inflation of the etheric foam never actually stops. It continues. So and the overall foam continues to expand exponentially forever. Occasionally, a local region of the foam slows down, cools, and crystallizes into a stable Calabi-Yau manifold. This creates a bubble universe. So there's trillions upon trillions of these bubble universes. In our view, our entire observable universe is just a single stabilized bubble floating with a wider, eternally boiling, higher dimensional etheric foam, where every different bubble represents a different valley on the landscape, a different geometric shape for the hidden dimensions, and a completely different set of physical laws. So basically, what Ron Cowan observed was we had a bounce that occurred at the start of our universe, and then everyone realizes there's this cosmic microwave background energy was there from something that occurred 13.8 billion years ago. So the simplest explanation that you can come up for this is it wasn't the bounce. This was, in fact, our universe hitting one of these other universes, and that created this reverberation there. But there wasn't any bang when the inflation took place here. And as we said, the inflation continues to this day. In standard relativity, the electric and magnetic fields are bound into two forms, and they're called the Faraday tensor, or F. And so, utilizing the Hodge star operator, which computes the geometric dual of a form, we construct the complex self-dual electromagnetic two form, which is the form plus the square root of -1 times the Faraday form. And then, because it's self-dual, meaning that the complex conjugate is minus square root of -1 times F, Maxwell's equations in free space achieve their ultimate modern compactification, that the exterior derivative of this two form is zero. What could be prettier than that, where D is the exterior derivative? So this single complex geometric statement contains all of classical electrodynamics, effortlessly linking the topology of space, the algebraic properties of the complex plane. Nikola Tesla entered into these activities. He was a man of the 19th century, and he had a very mechanical worldview. His engineering triumphs were built on the foundational physics of Michael Faraday, James Clerk Maxwell, Lord Kelvin, and because his entire mental model of the universe relied on an all-pervading material, luminiferous ether to carry electromagnetic waves, Einstein's abstract geometric spacetime was something that Tesla flatly rejected. His critiques generally fell into two categories. Tesla's most famous public broadside against relativity came in an interview on his 79th birthday in 1935. The theory of relativity is a mathematical, magnificent garb which fascinates, dazzles, and makes people blind to the underlying errors. The theory is like a beggar, clothed in purple, whom ignorant people take for a king. His exponents are brilliant men, but they're metaphysicists rather than scientists. Now, Tesla was an experimentalist, and he felt that the theoretical physicists were abandoning real-world experimentation in favor of abstract equations spun out into fantasy. For Tesla, all matter comes from a primary substance, the luminiferous ether. Yeah, the ether itself, as it condenses and so forth, this is how particles get created. This is how we have matter and dark matter get created. Tesla saw this in a series of experiments, but unfortunately, for Tesla, other people didn't accept his experiments. Tesla found that the core premise of general relativity, that mass warps the geometry of space and curvature is what we perceive as gravity, to be philosophically absurd. I hold that space cannot be curved for the simple reason that it can have no properties. It might as well be said that God has properties. He has not, but only attributes. And these are of our own making. To say that the presence of large bodies, space becomes curved, is equivalent to stating that something can act upon nothing. So for Tesla, space was merely an empty container or an arena, and if a body moved or curved, it had to be reacting to a physical material force through the medium, the ether, not interacting with the emptiness of space itself. So Tesla also dismissed the idea that matter and energy are interchangeable. He clung to the strict conservation laws of classical mechanics, where mass is entirely unalterable and force is merely a function of matter. And he called the concept of atomic energy illusionary and absurd. comparing the idea of converting mass into energy is saying the human body could be converted into a human mind. So there you have it. And Tesla's mechanical intuition made him an unparalleled genius in electrical engineering, but he had difficulty transitioning to the 20th century world of modern physics. Tesla claimed to have developed his own dynamic theory of gravity that explained the phenomena of the universe through simple mechanical actions in ether vectors without relying on curved space, but he never fully published its mathematical details, and history has moved past Tesla's objections. We have observations of gravitational lensing, atomic energy, and modern global positioning system grids that have repeatedly validated Einstein's mathematical garb as an accurate description of physical reality. It doesn't mean that Tesla's is not a valid description. It just means that we don't have it, and that what Einstein did have, people are familiar with. So to answer the question of how photons can be both particles, photons, and waves, uh, we have to bust a common myth. A photon does not physically morph or shapeshift from a ball into a wave. Instead, light is a single quantum reality that possesses both characteristics simultaneously. How it manifests depends entirely on how we look at it. So this is how this duality works in practice, broken down by whether light is traveling or interacting. By the way, I forgot to mention this is a picture here of a two-dimensional picture of a six real dimensional Calabi-Yau manifold. And so you can see there's a number of holes here, there's a number of uh, curvatures here all over the place. This is a non-trivial piece of topology to play with. And this is just one. Remember, we have 10 to the 500th of these. So when a photon's released by a source, like a star or even a light bulb, and it travels through free space, it stops acting like a localized bullet and begins traveling as a wave of probabilities. While in transit, a single photon doesn't exist at just one definite point. Instead, its quantum state spreads out through space. So the equations that describe where the photon might be are exactly the classical wave equations derived by Maxwell. The crests and troughs of the electromagnetic wave represents areas of high and low probability. So if this traveling photon encounters an obstacle, like the two narrow slits in the famous double slit experiment, the probability wave travels through both slits simultaneously. If it interferes with itself, just like a ripple in a pond, so a photon becomes a wave when it is left alone to propagate. It dissolves into a wave of potential locations. The transition back to a particle happens the exact microsecond the light wave hits something and exchanges energy. This is called wave function collapse. Imagine that a spreading probability wave finally hits a digital camera sensor or the retina of your eye. The wave is spread across a wide area. It cannot deliver half of its energy to one pixel and half to another. In the instant the wave interacts with an atom in the sensor, the entire spread out probability wave instantly snaps down or collapses into a single localized point. All of the wave's energy, that is the energy which equals Planck's constant h times nu. Nu is the frequency of the wave. It's 10 to the 14th hertz, something like that. And the momentum are instantly deposited into that one single coordinate. So to an observer, it looks as though a localized bullet, which is a photon, suddenly materialized out of nowhere and struck the target. Pretty amazing. So to summarize, we should think of this like a post office. Imagine a literal shape-shifting particle. Think of a photon like a piece of mail. The photon is the letter. You drop a distinct localized letter into the mailbox. The wave is the postal network. Once inside the system, the letter's exact path becomes a blur of logistics. It travels across broad infrastructure, sorting facilities, and routes simultaneously. It exists as a broad potential of delivery. And then the photon, upon delivery, when the mail carrier drops it into the specific destination mailbox, it instantly becomes a single localized physical object in one spot again. So light travels as a wave, ripple of possibilities through the universe, but arrives as a particle, a localized packet of energy. So there you have it, our current thinking of what's going on. Have a good